Alright guys, welcome to this page of the notes. Now what we're going to do here is you should remember on the previous page, I gave you a couple of example problems where I wanted you to identify which of the four common types of graphs we had. But what you noticed in a couple of them is that they had been moved, right? My parabola didn't go through the origin. My absolute value didn't go through the origin. The vertex was not at the origin. And my identity function, my linear graph, did not go through the origin. They had all been transformed. And that's what we want to talk about now, starting on this page of the notes. So here's the definition. Transformations. There are three types of transformations that we're going to discuss. And what they do is transformations that are performed on the parent function will then create one of the members of that family. You'll take that parent function, which does have a vertex for the parabola and the absolute value at the origin, or the linear function going through the origin. And we're going to take that graph and we're going to move it up, down, left, right. We can flip it over, right? Tons of transformations we can do, and that's what we're going to look at here. Three transformations that we're going to take a look at. Let me highlight them for you. We're going to look at translations. This is going to be where we move the graph up, down, left, or right. So we're going to go ahead and take a look at those types of transformations. We're going to talk about reflections. This is where you're going to flip the graph across one of our axes, either across the x-axis or across the y-axis. And then the third one is going to be a dilation. This is where we're going to be stretching or compressing our graphs, right? If you take the absolute value, for example, right, it's a v, right? If I were to stretch my absolute value graph, right, it's going to make that v really skinny, right? A nice skinny v if I kind of stretch that guy. Or if I have that v and I compress it, right, I'm going to kind of flatten that v out as I compress my graph. That's what we're talking about here with dilations, which are going to be stretching or compressing our graphs. So let's go ahead and jump right into it. Ton of information in this next table. And guys, unfortunately, there's not a whole lot here I can do to help you. You're just going to have to take your time, go through this chart, incredibly important chart, and really kind of memorize all of these transformations. Now, I'll do the best I can as I go through them with you, but it's really going to be up to you, right, to really get these down. Remember, like I said on the first page of the notes, this is not going away. We are going to do transformations. These transformations in every single chapter from here to the end of Algebra 2, all right? So if you don't learn it here, it is going to haunt you for the rest of this course. Please make sure that you get them down now so that later on when we get to chapter 3 and I say, hey guys, remember transformations? Well, here we go. You've already learned it. It will make that transition a little easier. When we get to chapter 4, say, hey guys, remember transformations? Here we go, right? It's going to show up in every chapter. All right, here we go. The very first transformation is going to be this. If you are given a function, all right, and it's normally going to be f of x, what we're going to do is we can put a number inside the parentheses with x, and that's exactly what they're showing you here. I am putting a number h inside the parentheses. I can either have x plus h, the quantity x plus h, or I can have the quantity x minus h. Here's the reason we call it h. H stands for a horizontal shift. This is going to be taking that parent function and moving it to the left or to the right. Sorry, for you guys, to the left or to the right, right? So moving it left or right. So that's going to be h, a horizontal shift. That's why we call it h, horizontal shift. However, h is tricky, all right? Follow me here. When you have a positive h, when h is a positive number, it is not going to be a shift in the positive direction. It's actually going to be a shift in the negative direction, all right? So whatever h is, if h is a positive 2, you're going 2 units to the left. Sorry, 2 units for you guys, right? To the left, 2 units to the left. If h is a negative 5, you're going to be going 5 units to the right, right? H, the horizontal shift, is the opposite. The direction you move is the opposite of the sign of h. All right, so we'll take a look at that in just a second when we get to some example problems. The next transformation is going to be this k, right? So you're going to have then outside the parentheses, right? I've got my f of x, the x is inside the parentheses, and then outside of that I have a plus k or a minus k. K is going to be the vertical shift. Why don't they call it V? I don't know. They don't. They call it K. Nobody asked me my opinion before they did it. They just called it K. Probably has something to do maybe with like the Latin or Greek word for vertical shift, or something to do with vertical. Maybe it starts with a K. I don't know where it comes from. Sometimes on the periodic table, right, when you're talking about the abbreviations of some of the elements, you're like, where did they pull those letters out of? Most of the time it actually comes from that element's name in Latin is where they get those abbreviations for. Could be the same thing here. Where does that K come from? It could be for the translation for vertical shift in Latin. I don't know. I'm just guessing. But whatever. They call it K instead of V. Get over it. It is what it is. The nice thing about K is this. Unlike H, which is flipped, right? If you have a positive H, you go left. If you have a negative H, you go to the right. Okay, it is what it is. K works exactly like you would expect it to. If K is positive, you go up. And if K is negative, you go down. Fantastic. Makes it easy. The next one that we're going to look at is reflection. Now, the reflection is going to be taking your graph and flipping it across the x-axis, right? So if you have the absolute value graph, which is a V opening up, if I put a negative sign, right, if there's a negative sign in front of my function, which we'll look at here in a second, I'm actually going to take that V that's opening up and I'm going to flip it across the x-axis and now be a V opening down. If I have that parabola, right, that U-shaped graph that is opening up, I'm going to flip it across the x-axis and it'll be that U-shaped graph opening down, right? That's if I have that negative sign out front. So we'll watch out for those reflections. And then down here in the dilations, we just need to worry about these top two with A. And what's going to happen here is this is going to be a number multiplied again in front of your function. So if you have a minus sign in front of your function, it's going to flip the graph. If you have a number out here in front of the function as well, that's going to be a dilation. One of the things that we had growing up, you guys may still have it, is that fruit roll-up. I haven't seen a lot of kids bringing them in their lunches anymore, but it used to be this thing. You would unroll it. It was this fruit snack, and it came out in this sheet, and it was kind of like a gummy fruit snack, but it was just in a sheet. And they had these little designs in the fruit roll-up that were kind of stamped out. You could punch out those little designs, and then what would happen, a lot of kids kind of playing with their food before they'd eat it, you could grab onto that design and you could stretch it, or you could compress it down into a roll, into a ball, and eat it that way, these gummy snacks. That's kind of like what's going on here with our graphs. If the number in front of the function is a number greater than 1, right? So we're talking 2, 3, 4, 5, any number greater than 1. This is going to be a stretch vertically. What you're doing, right, if you grab that fruit snack and you stretch it out, right, you're kind of elongating that fruit roll-up, that fruit snack. We can do the exact same thing to a graph, right? For example, if I have the absolute value graph, right, I have that V centered at the origin. If I multiply a number in front of that absolute value of x, what I'm going to do is I'm going to grab that graph and I'm going to kind of stretch it vertically, right? And what that would do to my V as I stretch it vertically is it's going to shrink that V up, right? It's going to make it a narrow V. Same thing if I had the parabola, that U shape. If I stretch it, it's just going to tighten that U up, make it real thin, a thin parabola. If that number in front of the variable, or in front of the variable, if the number in front of the function is a number that is less than 1 but greater than 0, it's a fraction, right? You have a decimal less than 1 or a fraction. What you're going to do is that is going to be compressing the graph vertically, right? You're just going to be kind of compressing that graph down. Well, think about it. If I have that absolute value, which is a V, and I begin to compress my graph, I'm going to take that V and I'm going to kind of open it up, right? I'm going to make that V much wider, right? Or if I have the parabola, right, that U-shaped graph, and I compress my graph by putting a 1/2 or a 1/4 out front, I'm going to make that U much, much wider. It'll be a much fatter U. So those are all of our transformations, the horizontal, the vertical, the reflection, and the dilations. And now what we're going to do is let's just get some practice with those. So head on over, hold up, I apologize. Before we go to the next page, one more thing I need you to look at. These guys right here, you will need to memorize these functions, these generalizations. Let's not even call them functions. They're generalizations, and because I am going to ask you questions about them both on the test or the quiz, and here's the way they work, right? The first one, I've given you the identity function. So remember the way this is going to work. If you have a number inside the parentheses with the x, that's going to be your horizontal shift, and it's the opposite of the sign. The k will be on the outside of the parentheses, plus or minus a k tacked on to the end. And then the number out front, the a, is going to be the dilation. Are you stretching it or compressing it? Same thing with absolute value, except instead of parentheses, you have the absolute value signs. Anything inside the absolute value is going to be your horizontal shift left or right. Remember, it's the opposite of the sign that you're given. K will be the number tacked on the end. A will be the number in front. And then the quadratics, right? You're going to have something in parentheses squared because it's quadratic. So if there's a number inside the parentheses with the x, that's going to be your horizontal shift. The opposite of whatever sign you're given will be the direction you go. K will be a number tacked on the end. A will be the number out front. That'll determine whether you're stretching or compressing that quadratic, that parabola. All right, so these are going to be our general functions. Again, please take a second. There's nothing I can do here to teach these to you. You just have to memorize what they look like, and we can do that by getting some practice. So head on over to the next page. We'll take a look at actually graphing these functions. I'll meet you there.